welcome to this video on optimization. And optimization means to find the optimum or best value of something. This could be a maximum, all right? If, for example, if we talk about profit versus number of items made, we'd be looking for the maximum where the derivative is 0. But if we talk about cost, it might be a minimum. So optimum is the generalized term for the best value. Okay, notice that at the minimum, the derivative is also 0. So what we want to do first is we want to create an expression for the quantity we wish to optimize. Then we can differentiate it and equate it to 0. However, our expression must only have one variable. We're going to look at 4 examples. The first one is a rectangular rug which has an area of 9 meters squared. What should its dimensions be to minimize the perimeter? Perhaps you want to pause the video and try this yourself. Here's a picture. Right, so our perimeter is twice x plus y. Right, the problem there is that we've got 2 variables. However, we know that x times y is 9 because the area is 9. So we know that y is 9 over x. So the perimeter now is actually 2 brackets x plus 9 over x. And we now have only one variable. The graph of that looks like this. And we want to be here. Right, so what we're going to do now is we're going to differentiate it. We haven't differentiated it yet. We've got it kind of flat, ready to differentiate it. We differentiate it, we equate it to 0, and we solve, and we get that x equals plus or minus 3. Obviously, in this context, x can only be positive 3, and so in fact, the rug ends up being square, 3 meters by 3 meters. The next example we're going to look at is very different. It involves some trees in an orchard, each of which contains 50 apples, 50 trees, and the current price per apple is 1 rand. Each week the price per apple increases by 10 cents. Good news. However, each week an apple falls off each tree. Now this question is scaffolded. It asks us to do 2 parts. Firstly, it asks us to show what the crop is worth after n days, and then it says when should we harvest the crop to maximize the profit. Again, perhaps you want to pause the video. Firstly, we need to work out what the crop is worth after n weeks. Well, after 1 week, there would be 49 apples on each tree. After 2 weeks, there would be 50 minus 2. So after n weeks, there'd be 50 minus n. And the price increases by 10 cents per week. So the price after n weeks is 1 plus 0,1 n. So after n weeks, the crop will be worth 50 trees times the number of apples per tree times the price per apple. Right? That simplifies out to the expression that we were required to answer. So that's the end of part A. Really important idea is that even if you couldn't do part A, you can use that to solve part B, because all we now need to do is differentiate this thing, equate it to 0, and solve, and we find out that 20 weeks gives us the optimum return on our crop. Next up, we're going to look at a cylindrical tin. It's got a volume of 340 mils, that's 340 centimeters cubed. What should the radius be to minimize the amount of metal used? Right, well, if we think about opening up a tin, it's made up of 2 circles and a rectangle. Right, that rectangle actually has, the circles have an area of pi squared each, so 2 pi squared. The rectangle is the side folded out. It has an area which is equal to the circumference, 2 pi r, times the height, okay? The problem with that formula as it stands, I'm just going to go back there. The problem with that formula as it stands, it's got 2 variables in it. Remember, pi is not a variable, it's a constant, but it's got r and h. Okay, however, we know that the volume is 340 mils. Now the volume is the surface of the top, surface area of the top times the height. So we can get an expression for height in terms of radius. And now, if we put that into our formula, we've now got an expression for the amount of metal that we're going to use. If we had to draw that graph, it looks like this. There's the metal used versus the radius, and we want to be here. How are we going to get here? We're going to differentiate, equate to 0, and solve. We haven't differentiated yet. Now we've differentiated it, equate to 0, and solve, and we get a final answer of 3,8 centimeters for our radius. The last question we're going to look at is this one. Right, a right-angled triangle has one vertex at the origin and one on the curve, negative 0,2x squared plus 8. Let's just have a look at what this looks like. Okay, so here we've got a simulation of this, and we can see that as we move along, the height is decreasing, but the base is increasing. The area is actually getting bigger, and it seems that at around, we seem to be able to get to the area to about 9,74 when we've got about 3,6. Okay, and then it starts to get smaller again. Okay, and the question says, suppose B is the point C0. What value of C will maximize the area of the rectangle? Well, of the triangle, sorry. We know that the area of a triangle is half base times height, right? So there's the base and there's the height. So in fact, we know that it's going to be half times C times height. Again, we've got a problem because we've got two variables. What we need to know is, what is the height of that triangle? Well, that point A is not just any point, it lies on the parabola. So it has the same x value as B, right? In other words, it has an x value of C, but because it lies on the curve, every point that lies on the curve has that relationship between its x and its y values. There's the equation for y, and there is the y value when we have C as our x value. Right, so now what we've got, we know the height, because the height is just the y value of that point A. And now we have an expression for the area which only involves one variable. And we can differentiate it, and we can equate it to 0, and we can solve, and we get the maximum area of 9,74, and that happens when C is at about 3,65, as we saw earlier. Right. In conclusion, create an expression involving only one variable for the quantity we wish to optimize, differentiate it, equate it to 0, solve, and then make sure you've answered the question. Sometimes the question wants the value at which the optimum occurs, sometimes they want the optimum value, and sometimes they want both. Right, just to finally close it out, if I have a piece of rope 100 centimeters long, I wish to cut it into two pieces and make a square and a circle. Interestingly, if we use all the rope for the circle, that will give us the maximum area. What should the side of the square be to minimize the total area enclosed? As a hint, let the side of the square be x, and the answer you should get is 14. Hope you found this video useful. Have a great day.